In this video, I would like to prove that if an is any sequence that is bigger than 0, and if the sum of an converges, then it's also true that the sum of square root of an times an plus 1 also converges. So the way that we're going to prove this is we're going to use the AMGM inequality. And what this says is that if you have two real numbers, a and b, that are each greater than or equal to 0, then the geometric mean of a and b, so that's the square root of a times b, and this is always less than or equal to the arithmetic mean of a and b, which is a plus b over 2. So maybe you can see how we can use this inequality in this case. If we look at the square root of an times an plus 1, so this is going to be less than or equal to an plus an plus 1 over 2. And then we can use the fact that the sum of an converges, because here we have an and then here we have an plus 1. So we know in particular that 1/2 of the sum of an, that should converge. And then we also know that 1/2 of the sum of an plus 1 should also converge, because an plus 1 is the same as an. You just kind of start the sequence one term later. So we know that both of these converge, and then we can say that because square root of an times an plus 1 is less than or equal to this guy up here. So we also know that the sum of square root of an plus 1, so this is less than or equal to an plus 1 over 2. And then because this bigger sum converges, we know that the smaller sum converges by the comparison test. So that proves that this series right here converges, and we're done.